Our analysis of quadratic functions will begin now, and the idea is that we want to name features of the function and be able to move between representations of the function. And so to start, we're going to look at the algebraic form and just try to connect it to the graph. Generally, that's pretty easy, question mark. So we're going to look at the base graph, and so here it is again, so just x squared. Okay, and so we have its basic parabola shape, okay, fine. And then we look at this function graphically and see if we can connect anything. I know I just have x squared, and this place where it seems to be the bottom of the U shape, it seems kind of crucial. Okay, how do you find it? Okay, well, what I notice first is that it seems to be the place where it meets the horizontal axis, right? If this is the x-axis and this is the y-axis, it meets actually both the axes there, but maybe horizontally, right? It's more important because it's on the left side it would be falling until it reaches this point, and then on the right side it's rising. Okay, so it goes from decreasing to increasing at that point. So that x value might be kind of important. Okay, and so the this place is indeed important, and it actually has a specific name among polynomial functions. It's called a root or a zero. Okay, and I'm going to probably mix the two bits of language, but they're equivalent. Okay, a zero or a root of a polynomial is just a function. It's a number r, and such that if we substitute r into the polynomial, we get out zero. Oh, okay, so it's really saying replace x with r in the function, and if you do that, the whole thing should go to zero. Okay, so r would be a zero or a root. That's r. R is for root. Okay, but so now we can see that in this case, zero is a root, right? Like this is just, so this place is when r is equal to zero. Okay, so I can see visually that this is a root. But how do I, go about showing that more algebraically? Okay, or more generally, how do I do it with other polynomial functions? And the answer is do the math, do the definition. Okay, so you must solve p of x is equal to 0, okay, which really means that in this case of a quadratic function at least, that ax squared plus bx plus c is equal to 0. And so we have really two tools to do that. We can factor, okay, and if we factor, right, we might be able to pull out that a value and then express it as x minus r1 and x minus r2, so two binomials, right, is equal to 0. And then we can use from here to here, we use the zero product property, okay, which says that if we have, a times b is equal to 0, then that means that a is equal to 0 or b is equal to 0, okay, and then just solve, okay. The other tool that we have in our toolkit is the quadratic formula, okay. Now, the value of x, so your values or your roots or your solutions, not solutions, zeros, are just going to be whatever x is equal to on the other side. So this is going to be your 0 or your root. Okay, now you see there's a bunch of a, b's, and c's in here. Those all come from the a, b, and c from your quadratic formula. Okay, so I'm just going to say a, b, and c in there come from that equation. Okay, so either route works, but you have to be ready to do either one. Okay, and one route might be easier or more difficult than the other. All right. Generally, the quadratic formula takes me more time, so I try and factor if I can. If factoring fails, then I go to the quadratic. Okay, so let's find the zeros of each of these functions. So I have f, g, and h. Okay, I'm going to try factoring first. This first one, if I do it, let's see, this one I recognize as a factor pattern of x minus 3 times x minus 3. Okay, so if you need help factoring, that's a prerequisite skill for all this. And so if you have questions, might need to review factoring on your own or consult me outside of class on this. And so then I would say, okay, this according to the definition, I need to set the polynomial equal to 0 or the quadratic function equal to 0, solve each one independently, okay, and they're repeated, so I'm going to write them out both, but you don't really need to. And so I'm just going to say x is equal to 3, and x is equal to 3, okay? So really the only 0 is going to be x is equal to 3 here. It's a repeated root, a repeated 0, okay? Next one, I'm going to try to factor this. So let's see, again, I know what this factors as x minus 3 and x minus 1, and I'm going to set that equal to 0, okay? Solve each factor, use the zero product property, set each factor equal to 0 and solve, okay? X is equal to 3, x is equal to 1. I have found my 2 roots, or 2 zeros, okay? And my last one, that could be interesting to try and factor. I might be able to, but the 2 is giving me a little bit of anxiety, so I'm just going to, not even try factoring. I'm just going to use the quadratic formula, just for a change of pace. Okay, so this is A. This in here is B, and this is C. Another thing you could do is just go off to the right and say A is equal to 2, B is equal to minus 1, and C is equal to 3. Okay, and then go ahead and use the quadratic formula. X is equal to negative B, so 1, negative of a negative, plus or minus square root B squared, so this would be negative 1 squared minus 4 times A, 2 times C, 3, all over 2A. Okay, and so I get 1 plus or minus, denominator here, inside the square root I get 1 minus 8 times 3 is 24, okay, and then over 4, and this is going to be positive 1 plus or minus square root of negative 23 over 4. Now in this course, we don't deal with complex numbers or imaginary numbers. So we're just going to say there are, since we have a negative underneath the square root, which is impossible, I'm just going to say no real zeros. Okay. I would have some imaginary ones, but we're not going to talk about them. Okay. And so that's how we can find zeros. Okay. Factor or use the quadratic formula. In the case of factoring, factor it and set it equal to 0 and set each factor equal to 0. Okay. Now, how does this connect to the graph? Okay. Zeros are the places where, if we look at the definition, right, we put in an x value and our y value is 0. So we get the point r comma 0 on a graph. Okay. So in the case of one real root, I have my real root right here. So this is my 3. This is my value of r. Okay. In the case of 2 real roots, I have it intersecting the horizontal axis twice at 1 and 3 in this first case, or the second case. And in the third case, where I don't have any real zeros, that means it doesn't touch the horizontal axis at all. Okay. So I have something like this, okay, where it's wholly either above or below the horizontal axis. And in fact, I can, without even doing the calculation for the exact values of the zeros, I can actually determine whether I have 0, 1, or 2 zeros based on what we call the discriminant. Okay, and this is a property of the quadratic form or quadratic function, but the discriminant is just that value underneath the square root in the quadratic function, the quadratic formula. Okay, under square root of quadratic formula. Okay, okay, there we go. So then how we use this is that if the discriminant is positive, we say there are 2 real zeros. Okay, if its value is 0, then there's 1 real zero. And then this multiplicity idea, we'll talk more about that later. And then negative, if the discriminant is negative, then there's no real zeros, okay? And so if we look at this function, okay, and calculate the discriminant b squared minus 4ac, okay, this is, so I'm just going to come off to the side. A is 2, b is the coefficient of x, which is 1, and c is negative 5, okay? So if I come over here and say, okay, b is 1 squared, and then minus 4 times a times c, okay, this is 1, and then let's see, minus 8, and that minus 8 is multiplied by a negative 5, so plus 40, 41. Okay, so this just tells me that there are 2 real zeros. Okay, so that's awesome. And then I can just say, okay, well, maybe this would prevent me from having to do more work and finding them if, for instance, there aren't any. But now, how do I go about finding them? Well, I can either factor or use a quadratic formula. The upshot of finding the discriminant is that if you do the quadratic formula, negative b plus or minus square root of b squared minus 4ac all over 2a, if you found that b squared minus 4ac, this is the discriminant. Okay, so your calculation-wise, when you're going through doing the quadratic formula, your calculation is actually speeded up or sped up, speeded up, sped up, whatever one's correct. Plus or minus square root of 41 all over 2 times a, so that's 4. Okay, and so there I've gone ahead and found them. And if you really wanted to, you could write them out as 2 points, so like -1 plus square root of 41 over 4, and then comma 0, and then the other 0, the other value on your horizontal axis would be -1 minus square root of 41 over 4, comma 0. Okay, and there you go. Okay, so zeros of a quadratic function are the places where it intersects the horizontal axis. That's what we saw before up here, and you could have 1 time it hits, 2 times it hits, or 0 times it hits, okay? And you can classify that based on the discriminant and find the zeros based on either factoring or the quadratic formula.